Your database tests shouldn't require a real database connection to be reliable. We'll demonstrate how to use AsyncMock to simulate database responses in FastMCP tools, letting you verify tool behavior without external dependencies. You'll see the exact pattern for mocking async database calls while maintaining clean test assertions. From Unitist, mock import AsyncMock. Async def test database tool. Server equals FastMCP, data server. Hash mock the database. MockDB equals AsyncMock. MockDB, fetch users, return value equals. id, 1 name, Alice. id, 2's name, Bob. At server tool. Async def list users, list. Return await MockDB, fetch users. Async with client, server as client. Result equals await client, call tool, list users. Assert len, result data equals 2. Assert result, data 0 name equals Alice. MockDB, fetch users, assert called once. This demonstrates the mocking pattern combined with in-memory testing for isolated unit verification. The test creates a self-contained environment where external dependencies are replaced with controlled mocks, while the server and client communicate directly without network overhead. What makes this distinctive is how it validates behavior without requiring real infrastructure or complex setup. The approach works by substituting real dependencies with AsyncMock instances that return predictable responses, then exercising the system through the same interface clients would use. The in-memory transport eliminates external variables, making tests deterministic and fast, while the mock assertions verify exact interaction patterns. This separation of concerns lets you test business logic independently from infrastructure concerns. This pattern matters because it creates reliable tests that run in milliseconds, catching regressions early without requiring deployed services. It's particularly valuable for testing RPC systems, where you need to verify both the tool interface and the underlying logic, while avoiding flakiness from network conditions or external systems. The trade-off is that you must explicitly mock all dependencies, which can become verbose for complex scenarios. Let's break it down. From Unitist, mock import AsyncMock. Imports AsyncMock from Unitist, mock enabling mocking of async functions. This is essential for testing async database operations without real I/O, keeping tests fast and deterministic. Async def test database tool. Server equals FastMCP, data server. This defines the test function and initializes a FastMCP server instance named data server. The server acts as the container for AI callable tools, with each test getting an isolated instance to prevent state leakage. MockDB equals AsyncMock. MockDB, fetch users, return value equals. This creates an AsyncMock database instance to isolate tests from real database dependencies. The fetch users, return value is hard-coded to simulate a predictable response, enabling reliable assertions about the tool's behavior. This is the mocking pattern for testing async database interactions. At server tool. Async def list users, list. Return await MockDB, fetch users. This decorator registers list users as an AI callable tool on the FastMCP server. The async function's signature and return type hint automatically generate the tool's schema, while the implementation delegates to our mocked database for predictable test behavior. Async with client, server as client. Result equals await client, call tool, list users. This uses a context manager to establish a client connection to the FastMCP server, guaranteeing proper cleanup after the test block executes. The callTool method invokes the registered listUsers tool with an empty argument dictionary, simulating an actual AI tool call while maintaining test isolation. This pattern mirrors real-world usage while keeping test resources contained. FastMCP Async testing pattern. The combination of AsyncMock and PyTest's async fixtures creates deterministic tests for FastMCP's async tools, verifying both behavior and interaction patterns. A missing await on the mock assertions silently passes instead of failing, masking real test failures. This pattern ensures your AI callable tools behave exactly as expected under concurrent conditions.
The mock that verifies nothing verifies everything.